Ini pen right? Pen right?
Okay, perfect.
Better copy paste the desktop and we play from desktop.
President, we have to wait around 5 minutes because we wait for the student to come in. Okay. Yeah. Okay, no problem. No problem? No, absolutely.
Just cancel. Yes, this one. Very good. I use this one. So I think the S10 screen.
Okay.
Alright. So this one, we can use this one.
I can use here. Myself.
But
But it works?
Good.
Okay. Back is here.
Yeah.
Okay. And this is
Laser
pointer.
pointer.
Okay, it's perfect. Super. Works. All works perfect. Would be nicer.
Yeah.
More colors. Okay, good morning and assalamualaikum everyone. So I checked that most of our master students is currently in class. So, however, Professor Andrew will have a session, special session with the class tomorrow, right? So we will have more students tomorrow. And then with me here today is Professor Andrew from, it's very difficult to...
Wrocław University of Science and Technology.
Wrocław University of Science and Technology, Poland. So as far as I'm concerned, that the expertise of Professor Andrew is in testing or NDT testing. So and then Professor Andrew in his program under Erasmus Plus, where Professor Andrew needs to join or participate with the program to have collaboration with our university. So we take this opportunity to listen to his expertise and to seek any opportunities that we can join together in the future. So without further delay, I would like to invite Professor Andrew for the talk. So the topic is Advanced Testing Method for In Situ NDT Evaluation of Concrete Structure Case History. Thank you so much.
Thank you. Thank you very much. Welcome. We have a great honor to be here. First time in Malaysia. It is a result of the first visit from your Vice Chancellor at our university a year ago. So we try to build links, and because at the same time I represent civil engineering faculty, and at the same time I'm also responsible for my University of International Affairs, so we can discuss about research, but also we can discuss about the cooperation. So I have two faces. Let's say first few words about my country and about how to say. You know, we are from completely different worlds. In Poland now is -2 and snow. Here yesterday was 28. So first difference. Secondly, food is completely different. Absolutely different. Tradition is different. Ladies are different. Men are different. Your country is more clean as my country. Unfortunately, I have to say. It's but people are very similar, very open. Young people almost all speak English. In Poland, young generation is fluently English, but old generation not necessarily, mainly German. But old people are very open. And I found here in Malaysia that people are also very open. They are smiling, they like to help, they're interesting, and so on. So, even our background, our history is very different. Even our religion is completely different, because Poland is 98% Catholic country. But I don't know if in Malaysia is any Catholic people, but maybe yes. The same, we have very small minority of Islamic people, for example. So, seems to be a very big difference, but that's not. Because if the country is open, if people like to help, if people like to cooperate, they always can find something. And my general, let's say, message is that we can see very important agreements. Our politicians can make a lot of efforts, but we need person to person who likes to do something to us. If they like, they will do real cooperation. Otherwise, it will be only official and nice for documentation. Okay, so my field is generally testing structures, mainly non-destructive testing. It happens in my life that I met very special people all over the world. And maybe per accident, I'm a member of the Titan group, which is group especially the 10% in the world who are responsible for new development of non-destructive testing. So if you will be more interested later, I can give you contacts. And so all what is new in this field is coming through our hands. So I think I'm quite well informed. And I like to share my experience to you. I have no idea what methods is known for you, which is unknown. But I would like give the general presentation about advanced method, which I like to mention. A little bit background to understand if some things will be maybe not familiar for you. And then, for the second subject, case histories, I like to show some practical application, because it's always more interesting. What is in reality, not theoretically, but practically. And what I like to mention in the beginning, I'm not interested so much about laboratories. I'm interested about laboratories, mobile laboratories. We are doing testing on site. So we create a group which, if we get the message that around my town, 1,000 kilometers, not important which country it is, but it could be Germany, Czech, Slovak, Ukraine, and Poland, of course. If something happened, it's necessary to make expertise. We go by car, and after 24 hours, we are on site on the place. During 24 hours, we make the test on site, in situ. And next 48 hours, it's a report. So less than 1 week, we solve the problem. So we are very mobile. To do so, we need, first of all, skilled people, technicians and engineers and professors. We need skilled, good equipment, of course, and possibilities and experience. So let me start. I hope I will make it proper. I start with this slide, which is well known for you, but why? I think in any field, there is some milestones of development. When technology of concrete technology developed, people as we are have to be prepared to the new situation. Modern concrete, modern new technique to test it, to evaluate it. It's not enough that we will use old-fashioned, well-known laboratory tests, like an example, testing cylinders or cubes. By the way, you are from which part of the world? You test cubes or cylinders? At the laboratory.
From cylinders.
Cylinders. So you are more French tradition, because you know the world, as concerned the compressive stress of concrete, main quality parameter, is divided to two portions. One is doing cubes as a standard, 15 by 15 by 15. Second is testing cylinders like 15 by 30. It's almost the same, 20% difference. But okay, so you are cylinders, yes, more or less. What in your laboratory, which type of specimens?
Here we use
cubes.
Yes.
Ah, so you are from cylinders. Rest is from cubes. Okay, Poland is cube word. So we are from the same society. See? And I like to show some examples. This is one. For a long time, it was #1 in the world. Now, #1 is Dubai, Burj Khalifa. They built bigger one, but we don't know if they will succeed. What is interesting here, that they transport concrete to a level more than 600 meters. What is new advanced, of course it's advanced technology, but it's new needs how to do it. You have to change something. It's not simple. You cannot take it by basket and put 600 meters up. But at the same time, in your country, I'm sure, in my country for sure, we have such structures. Old, 40, 50 years old. Sometimes, like this one, 100 years old. It's one of the pearl of the crown of the concrete structures. One of the first concrete this scale structures built in the world in the beginning of 20th century, 1913. And we have to repair it. We have to maintain it, especially if there is heritage. How to do it is a one subject. But before we will repair it, renew it, modernize, we have to know what is the situation. And let's say our point of view is exactly the same as in the medicine. To be honest, real research, generally, in technical sciences, or generally, real development in research is going on only in two, in my opinion, in two directions. One, answer the question, how to kill human being. It means army application, cosmos. And second, answer the question, how to save human being life. It is medicine. And they have the real money, they have the real development. And when they found something, then we, as a technical society, try to adopt modern systems, modern concepts to our application. An example, when the medicine came to the market with ultrasonograph, which give possibility to check how is situation with the baby in the mother body, okay? Maybe we can see what is internal crack defects in the concrete structure. We make the picture of infra X-rays to see the bones is broken or not. Maybe we can make the same or similar with the concrete structure to find where is steel bars, how deep, what size, and so on and so on. So several approaches the same. We work like doctors for structures. We are mainly interested in concrete because concrete makes problems. Still, not so much. Okay. So the question is how to localize. The main subject which I prepared for this presentation is how to localize voice and delaminations. So we have the structure, we have the bridge, we have the building, we have whatever done, and there is some reason to answer the question, are inside any defects, any problems? It's extremely important because when we apply the load, suddenly from inside to outside will go stresses. And when we see the cracks on the surface, it's too late to do something. So we can use impact echo. It's no technique in your country. I think maybe not. Impulse response, ultrasonic measurements, ground penetrating radar, and infrared tomography. I would like to concentrate the first one because it's most promising in my opinion. But first, let's say, give you some impression, some example of what we really do. I think you know that the bridge in the sense of the span, number one is steel bridge Akashi Kaiko in Japan. But number two, the tallest, biggest bridge in Europe is in Denmark. It's a big belt, 1,653 meters span. And this concrete bridge was designed and built as a symbol of EU, European Union. All the best designers, companies, contractors, technology was involved, big money, to make something which will be symbol of European technology. And it is cable hanging bridge. These cables are anchored in the big blocks, concrete blocks. These blocks are the size of football field, so you can imagine. And of course, such a big piece of concrete you cannot cast one way, in one. So you need some. And the biggest problem which arises is how to cool the concrete during the hardening process. Otherwise, we have big gradients, and the concrete is not resist against tensile stresses and will be broken. So they found very advanced solution. They put inside plastic pipes with water, circulating water. And this system cooled down temperature with such big amount of cold. And it worked perfect. No cracks, nothing. But human being sometimes is very arrogant. He's so clever, so can make so stupid mistakes that it's difficult to believe it. What happened? Denmark, as Poland, is in the area where it's quite strong winter. It was unfortunately very strong winter before they opened the bridge. They forgot empty the pipes of the water when it was winter. So the water in pipes, what happened? Was ice, expand. And suddenly they found some cracks. The problem is not with cracks which you can see, but the problem is with cracks which you cannot see. You cannot remove the bridge and build the new one. You cannot, okay, we can repair by resin, by some modern technique, but how I have to know in such big amount of concrete where I have to inject? And this is our duty, how to test such structure to find how big is problem and where and what we can do. The second part is other people. They are specialists of technology or repairing, and this is other story. But my duty was to find where they are, these cracks inside. And fortunately we found it was injected, and as you see, the bridge is, but what is the result? What is the effect, political effect? The bridge was designed and built as the #1 in the world. But because of these problems, they delayed opening. And Japanese people were more smart, finished Akashi Kaiko before, and this poor bridge, concrete bridge, never was #1, it's only #2. So sometimes it happens like this. And it's an example how arrogant people, in this case, European engineers, can make stupid mistakes. So even you have the best technique, best education, remember that always you have to check, you have to be sure what you are doing. Because if I will ask you if it is possible, you would say, no, it is not possible. Why? Because it was absolutely top #1 project in Europe. And fall down. Okay, that's just impression. Impact Echo was designed originally by Americans to support quality control of concrete highways. American system required to make one core each 300 meters of highway to measure thickness. So after testing big highway, you have the big house of cores, and you have to repair it. Big problem. The Americans said, maybe you can find something which will allow us to measure thickness of concrete element when we have access only from one side to support quality control. Because if you can drill and you can measure all, that's simple. But if you have the container of water, you cannot drill because you will have column. You cannot drill each 100 meters or 300 meters highway because you can do it, but then you have other problems. So Impact Echo was found as a very modern technique to measure thickness of the concrete element which has access only from one side. How I will say after a moment. Generally, if we have the solid material like concrete block and we knock like this, or I can take the ball, steel ball, and I release, and ball will jump. Or I have the ball on the wire, elastic wire, and I put, boom, what I do? I generate in the solid material elastic waves from the physical point of view. These elastic waves are three types. One is P wave, primary, or compression wave. Second is shear waves or tensile wave, and relay waves, so it means waves which are going on the surface. We are interested in the first one, because this first one, well known also from the ultrasonic technique measurements, are more energy, so penetrate relatively deep. And the concept is, if I generate wave is penetrating and will touch backside, where it's end of solid and starts air. So has to reflect. And going back, when it comes to the surface, when we accelerate, the surface is a little bit movement, little bit. So we like to measure what time is necessary to go down and back. If I know the time, if I know the speed of the waves in the particular material, I can define thickness. Very simple. Well, maybe not so really simple, but I would say, of course, normally wave is like this, triangular. But we can avoid it because mistake is very small, and we can say that the total length of the path of the wave is t 2 times t, where t is thickness. So the travel by speed or ultrasonic pulse velocity, which is usually around 4,000 meters per second, we obtain delta t. Frequency is opposite of time. So we translate what we like to know, thickness, speed, divided by 2 times f, when f is frequency. And translation from time domain to the frequency domain is going by fast Fourier transformation. Not talking about the details. We obtain picture in which we get, okay, one moment. We get the amplitude distribution according to the frequency. And the frequency in which we observe extreme of amplitude shows information about the thickness. How? I will show you after a moment. And the method is extremely accurate. If you will have the plate, and you will measurements the plate 10 times, you get the 10 times the same almost results. Accuracy is less than 1 millimeter. It's unbelievable. Of course, if the thickness is changing, it will also change. What we need what is the speed, natural pulse velocity in the material. We can measure by ultrasonic technique, we can measure by other technique, which I also can show. We know it. And we know what we measured, so we can define extreme of frequency. So finally, we can find what is the thickness of material. But it's only half of interesting subject. This happens if the traveling wave has no any element which disturb it. Go and down. So we can imagine what will be the result. And suddenly we get something which is different. Why? Only one reason. Inside is air. Air is where? Air is only when it's crack, void of the lamination. Depends how big is this void, we have different result. So in this way, making book, we can answer it's solid or it's something inside. Even we not necessarily can always exactly define the size or localization, but we know here. So I can make now drill and make open and check. Exactly like in medicine. If you have the X-rays picture of your body and there is some light could be cancer. But by non-destructive, you found could be here cancer. Then the doctor takes piece of this, we make the core, and check, and we look, and we say, this is danger for destruction. Oh, it's not important. I also will give an example. So even if we not solve full problem, we can find where is the problem. And sometimes there's a question, why is this method is so simple and so efficient? Because from the physics point of view, acoustic impedance is defined as density multiplied by wave speed. And if you look to this table, you will see that for concrete, an example, this parameter is about 8 to 10 multiplied by 10 to 6. And look to air, 400. So it's 6 times bigger influence. That's why any empty air, because what we really find, we don't find cracks, voids, delamination. We find air inside. And then is a question to understand what type of air and what is the real problem. If I will not forget, please remember me to give another practical example because it's very interesting. And how it looks. The computer is standard, or maybe not really standard, but because it's safe, it's designed this way that if fall down from 8 meters, nothing happens. And if there is an electromagnetic disruption, it has also be safe. No one try with such computer fall down, but okay. And then there is an impactor. The main transducer, which costs $30,000, is inside. And there is wire and the ball. Depends what problem, how big structure is, we define different size of the ball. We take the ball and release. Boom. So generate waves. And then, as I said, it's going wave down and back, and then surface little bit move. This movement is registered by transducer, very sensitive transducer. And this is translated to the time domain, and by fast Fourier transformation, again, frequency domain. Just, sorry for this is a Polish site, but it will be very clear. Wzbudzenie, it is impact. Czujnik is transducer. And this is a testing element. So, Polish language you are familiar now already. So, we generate signal, is going down, reflect, come back, and what we get on the picture after Fourier transformation, such picture. There is a frequency, and it's in some place there is an extreme, top of frequency. And an example is 6.45 kilohertz. For this frequency, we observe extreme. Okay? If you put it to the equation which I showed before, you get that it's 298 millimeters. So it's almost 30 centimeters thick of the plate. And then next case, we have inside something. It could be orange, which was casted per accident. It could be crack, small, so void, I call it. Small, it means that the wave has enough energy that can go around. Okay? Partly is reflected, but most energy can go around. What it means, go around? Use long away. If it's long away, also time is longer than regular test. If time is longer, frequency is like shorter, because frequency is opposite of time. So then what we obtain? We obtain picture where it's 6.45, you remember, solid frequency, which is without nothing. And suddenly we observe extreme before. before expected position, it means for the smaller frequencies. If we see something like this, we are sure that there is a void. How deep? This part which reflected appear as the next. In my presentation, it seems to be very simple. In reality, it's not so simple. I will show you examples, but it gives such possibility. Second part could be not clear because other influences can change picture, clear picture. But this is absolutely clear. So if I have the unknown plate, I take my device and I make boom, I have the picture. Not important. I don't know if it's good or not. Boom, boom. I have always the same, but suddenly I have something different. So it means this is place which I'm interested in. Disadvantage is that it's quite time consuming. So you need some more time. But it can happen also as a situation that we have delamination. So we have big crack, an example, corrosion of the steel bars of the top of the layer. And then what happened? We expect here extreme, but we haven't. We have nothing before. We have only very big peak afterwards. What it means? Energy of my test is not enough to go around. Only can be reflected. And this value represents in which, how deep is the lamination. Okay, three, the same three together. Solid, small void, big delamination. The general concept. So we can find place where is something wrong inside. And we can say this big problem, big delamination, or could be small. We can localize where it is, and we can open and we can check. Practical application of this method. For what we can use it? First of all, measurement of thickness. An example, asphalt overlays, roads and pavements. Second, localization of crack, voids and honeycombing. It is also the other story. If there is a honeycombing, this mixture of the aggregate and air inside. And this, of course, weak place. This is not easy to, we have no time to explain exactly how we define it, but it's also possible. The lamination, we can integrate protective membrane below the asphalt. The bonding between reinforced and concrete because of the corrosion. And very important, maybe even most important situation. There is in fact no other method which allow us to check if cable ducts in the pressed structures is well injected. In fact, control is that we inject with special fluid, special mortar, and we observe by pipe when this is going out. But if it's well injected or not, you have no idea. And if the air is close inside the cable duct, earlier or sooner, you can expect corrosion. And unfortunately, when it's a pressed structure, like cable structure, if the cable will be corroded, just bridge will fall down. You have the example in Italy, not long ago, United States, the very well-known engineer from Italy who designed the bridges, and it was big collapse with cars on the transport. We can also give, you see the crack on the surface. But the question is, if it's only 1 centimeter deep, maybe 1 meter deep, it's done. It's not easy, because from the geometrical point of view, it has to be perpendicular to the surface. But more or less, we can say. I would like to say one thing. There is no in the world methods which solve all problems. You can forget it. But if you have nothing, even you can have more knowledge, little bit more knowledge, it's better. So usually the best is if you combine few methods. One method solves this problem, another, and finally you have the picture, information which for the skilled engineer can give the solution. And now I like to give you examples. How much time we have? Because I have to warn you. I'm enthusiast of my field, and I speak 24 hours. You have to stop me. So, and I like to have some discussion. We have till 12 or till 11? Okay, so yeah, I was afraid that 15 minutes. Okay, there is 3 selected examples. One is old bridge in Terespol. Terespol, it is small town on the border between Poland and White Russia. Why we tested it? For a long time after Second World War, Poland, of course, was an independent country, but belonged to Warsaw Pact, so to the socialistic countries. We were under Russian dominion. So we expected attack from Germany, Denmark, but Russia, White Russia, Ukraine, it was our friends. This is a bridge under the river, border river. Name is Bóg. When we joined EU and then NATO system, so situation was completely changed. Now our enemy now is in the east, so I mean Russia, Ukraine. Our friends are German and Denmark. German and Denmark. So, from the military point of view, it's very important capacity of bridges, because main transport is going by roads, tanks and so on. And now we have to recalculate all bridges on the transport lines, because very security information. Why? Because of stupid situation in Warsaw Pact, so in Poland, was reference point, where it's reference force, weight, which move on the bridge to check the bridge. It was tank T-26, I think, Russian, 30-ton weight. So force 30 ton is moving on the bridge. And the bridge was designed to such thinking that our tanks from east will help us in the west. When we opposite situation, now we expect that the German will help us. But in Germany and in NATO system, the reference point is Leopard tank, German tank, which has a weight 50 ton. Yeah? You see the difference? So to be sure that the bridges will not fall down, we have to. By the way, what is really funny, some years ago, we bought big amount of Leopard tanks from Germany. And you know, the words are changing, and suddenly, now it's, you know, a little bit stress situation because of Ukraine, because of Ukraine and so on. And now we have more tanks, German tanks, as Germany, because they have no tanks. They are not prepared for the war now. We bought the tanks from Germany, and now Germany has a lack of tanks. And suddenly, when the NATO check, let's say, how we are prepared for eventual war, they found that Germany is not prepared. Okay, so that was the reason. That was the problem. Second problem is Chełmno Bridge. Chełmno, it's middle of Poland, but way from Germany to Russia. Main heavy transport is going by this bridge. This bridge was in rather bad condition and was decision to make the test and to make the modernization of this bridge. And it's a good example about how people can be arrogant. if they are not enough clever. I will give you. And it's a story about the hole inside the bridge. But I will explain later. Next is Wisla. It's the first test in Poland. When I was with these modern methods, I invite our colleagues from abroad, and we invite all authority of Polish engineering authority to show them the new possibilities. And they selected one bridge, and we made during 2 days complete expertise of technical solution of the bridge Wisla. It was first. So the concept was to show to people who decide about money in our country that it's important to develop this direction, that to show that it works. And they came, and there's a very interesting story about this method, because first I was enthusiastic, then I was down, and suddenly I rise again. So, like, you know, like Phoenix from dust. Very interesting. And the Bełchatów is the tallest chimney, concrete chimney in Poland, 300 meters. And this is a story about if you will only drill the hole to take the specimen for the tests, regular cylinder tests. You have a lot of knowledge to have, otherwise you make stupid mistakes. And it's also unfortunate story about me, how young men can be stupid to lose a lot of money. But later, about the details. Okay, so let me start with first one. The bridge was tested with a regular, all necessary tests as we are doing with bridges. And we found that the deck has to be removed. No chance 50-ton tank will go. It was time when we were thinking that Germany will send the tanks to help us in the east. But okay, now our tanks also cannot go by this bridge. But supports maybe will okay. But the problem is that the bridge is under the border. 2 supports are, or 4 supports is in the White Russia, and 4 is Polish side. And we make the test of this support because, you know, to make such heavy work like checking supports on the border is not easy. All our work, we were under the big gun, both Polish soldiers and Russian soldiers, and you know, check and so on and so on. But how it is like this. So we tested the supports, and we found that 4 supports from the Polish side are excellent, but 4 supports from the Russian side is very bad quality. And the question is why? Because to make the proper solution, you have to understand why something happened. First, very simple explanation was Polish people, unfortunately, also arrogant, time to time. Of course, the reason is very simple. We have the good quality workers, we have the high technology, and the Russians are very old-fashioned, and they do bad quality, and so on. But the first impression, first solution, my colleagues. But then, I was there, I spent there, I think 1 week, because before and after, and I like fishing. I fish, and I met old men from the village, and we were fishing together, and I said, you know, tell me please, how it is possible that 4 supports are good and 4 is bad? Because you have to know, sorry, but one thing, before Second War, the bridge was built in 1970, something like this. It was Poland from both sides. Because we had Ukraine, it was part of Poland. So this explanation about different quality is not true, because both sides was made by Polish people, with Polish materials. And one is excellent or bad, and we don't understand why. And the old man told me, you know, they are stupid. Means people who did. When I was young, I was looking for the cows. I look what they do. They take the aggregate for the concrete with the natural sources in the forest. It was not special industry, just they had one source on the nowadays Polish side was very good quality aggregate. But other side, bridge, was very poor, a lot of sand, fine. So it's not good for the concrete. It has to be proper aggregate in size and so on. And of course, people usually lazy per definition. People lazy per definition. Because they don't like to make all aggregate from the good source and transport other side of the river and they use close by bad quality and make for not good and other side make good. So it was reason why appeared the problem. Okay, so if so, we now decided to make the test. And one of the supports were already repaired. They make coat, concrete coat around the old support, 15 centimeters thick. And there was a question, if the new concrete and old concrete work together or not? Because if not, even the situation worse as it was before, because this coat extra load support. And we make the test, and you can see here the extreme 150. What it means? It means that our wave penetrate, reflect from the air, and back. And thickness is 50 centimeters. What it means? There is no connection between new and old one. Other place, they showed 1 meter and 50 centimeters. So it means wave can go through, so it's a good connection. And finally, we found 75% of these places were wrong. So the decision was remove this support. Seems to be simple solution, but makes easier because we had such information. This is first story. Second story is about this Helmno bridge. The bridge is about from this level to the deck around 6-8 meters, depends on the situation. So quite far. The bridge was decision to make the renovation. So they make whole works, including new stone, painting, but they didn't make the test of the deck. They just look, oh, it's not too bad. Who will pay money for it? The price for the test was in this time 30,000 Polish zloty. It is easy for you to understand because 1 Polish zloty is 0.91 your currency. So it's almost the same. It's also easy for future because my price is almost your price. So it's in the shop is easy. So about 35,000 Polish zloty. So 35,000 green. So it's some money, but not very expensive. And they finished. They made the renovation, but without deck. Deck is good. Because they look good. Have to be good. Because why? Because human being is lazy per definition. And arrogant. So they know better. And moreover, I don't know how it's in your country, but in our country, it's many cases now to reduce the price that the designer of the modernization are also responsible for expertise, for technical expertise. And then, of course, don't like spend money for testing. They like to have money for designing. So they do it. But many cases they survive, but sometimes they lost. And the price can be very high. And this is a very good example. In Poland, we have system, permanent control of the quality of the bridges in the main roads. So there is a car who is driving one side, after a few hours going back, and registering if something happened, if there is an accident and so on and so on. And the car, it was Saturday, also, again, differences. In your country, 3 days is Friday and Saturday. In your state. In Poland, it's Saturday and Sunday. So Saturday it was just before Sunday. So people relax. It is summertime, and they found that on the asphalt layer there is something like this. Not hole, but they give the message to the headquarters that something is wrong. No problem, no problem. The boss is on the Mazurian lakes, they sailing, don't disturb him. Well, you will come back Monday and you will take the machinery, you will remove the broken part and you will make the new one. Okay. They came Monday. This. You see? Big machinery, boom, 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 boom. Suddenly 2 square meters of the bridge fall down. You see how it looks? Even steel bars were broken. No, in such situation, jobs are finished. Now starts time to come specialists. And what is strange in my work? Normally, no one like talk with me about tests because no one like pay money. But if happening like this, there's my time. They will pay any price because they are afraid that they lost. And it's no important. I can say any price. So I said, okay, we will come, but it costs you more money. Okay. And then we use this car, ups, and we take the simple hammer. From the 6 meters, you see, oh, nice concrete. If you go there, boom, boom, and suddenly 1 square meter of cover layer fall down. You see, part of steel bars already disappeared because of corrosion. When we make the core, you see 1, 2 even delaminations. So it's only per accident that there were not heavy transport accident. Because fortunately, lines of cars was painted this way that the wheels were going on the beams, not on the plate. If they go half meter or 1 meter left or right, then the wheel will go for the middle of the plate, which is weaker to light, and the car will fall down. So it's unbelievable. It's a luck in the bad situation. But so what we did? Okay, in this place, situation is clear. Has to be removed, has to be made properly. But what about the other bridge, Bahru bridge? 24 beams in one direction, and I think 14 span. And now I say, okay, we will test, we will tell you where it's wrong, but it costs money. Okay. We select other plates, we make the core, and you see the concrete is very good, the basalt aggregate, excellent. And then picture is very clear, 115. Thickness of the plate was 12 centimeters, so it was almost a little bit less because it's not very accurate, but when we get situation where it's solid, no problems, we obtain exactly frequency which shows thickness exactly as it is. But when we do the same in the place where core looks like this, where it was delaminated, you see there is a blue line that is representing thickness of the plate, real thickness, and we obtain yellow extreme after this. It means there is a delamination, because it would be small defect, would be this side. Later, and it's 100. So 2 centimeters cover layer on the top layer of the steel bars was simply delaminated and does not work together. And such places was in 8 areas which we tested. And then, I would like to remember you, 35,000 ringgit. Now 1.5 million ringgit they had to pay. So, not often, but sometimes, arrogant people has to pay. And then we are lucky. But you have to be still clever, because I did the mistake, I will tell you later, which shows that even if you think that you are clever, you are still clever. The first our experience. By the way, this man is Klaus German Petersen, person #1 in the world about this field. And this one is my oldest son, who was interested in and take part in the tests. And this man is, looks younger maybe, or more serious. Okay, so as I mentioned, all authority from Poland related to the civil engineering came one place. All people like to see what we found. And of course, as usual, in such situation, some people are very big enthusiasts. They like to introduce some news, but some people are critics. They critic. Yeah, well, they can find some news. It's stupid. A lot of money. Always like this. Always. And now you are in the situation that you have to prove that you are right. You are great. Now, in the beginning, I was very important because I presented. It seems to be logic, nice. Okay, they say, now show us. Okay, we're not testing, but all is okay. No problems. And finally, we decided to test the cable ducts, which is most difficult part of this test, if they are injected or not. And the thickness of the middle part of the beam, which is inside cable ducts, was 15 centimeters, 150 millimeters. You see here, this is an old style because it was first presentation without any of this modern computer color nice pictures. And this extreme shows 150. So it means in this place where we make this measurement, it's exactly thickness, is solid, nothing inside, good. We make, but we found a place where we're sure there is no cable duct. More or less we know where is cable duct. By other technique like radar, we can define exactly localization of cable duct. So we select a place where it's only concrete, just to have solid frequency. And we obtain this result. Then, you see in Poland is also sometimes hot, but not 38, 32 sometimes. And then we did the same measurement, but in the place where was cable duct. So we go with wave through the cable duct, which is injected or not, and back. And we obtain a little bit different picture, but again 150. What it means? It means in this place, cable duct, which was well injected, and the wave goes through like solid. But finally, we found one place when we obtain something like this. This is frequency which represents 150 thickness. And we obtain extreme before 9.8, so it means it represents 200 millimeters thickness. But we know that the thickness of the beam cannot change 5 centimeters. So something is wrong. Wave go around. So inside this cable duct is empty air. Theoretically, yes? You understand? Yes. Okay. So we say, oh, please, here we have empty area inside. There's no injection. And what people said? Okay, please, show us. Open. We like to see. And you know, you are like magic. You're sure that you know what you do, but you are still afraid, maybe I made a mistake. And there is a moment in which if you succeed, you are great. If you're not, you can forget, you are lost. They will not maybe officially joking and smiling, but they will do when you will not see. Absolutely, 100%. So, okay, we found the place and we drill. We drill and we obtain something like this. Perfect silver cables, no corrosion, full injected cable duct. So it means that we make mistake. I dropped down, but fortunately my colleague from Denmark, said, Andrew, relax, relax. You have to be like Jesus Christ. I don't know if you know the story. When Jesus Christ came back, they met his friends, and they didn't believe that he really came back. So, and one of them was not there. And when he came, they told him story. And then he said, no, I will not believe if I will not put my hand to his body inside, to the where was open. And exactly the same. He said to me, Andrew, take your hand and like Jesus Christ, put inside, and then you will understand. Don't be believed. Don't be. How to say? You have to believe. Okay. And what happened? The cable duct is a steel pipe, and per accident, in this place, steel pipe was deformed. It was not round, but was. Understand? And the cable was excellent injected, but what we found this black area where I put my hand like this, and I again rise as a big guy because we found what is the message from this? First of all, if you are really skilled, you have the knowledge, you have to believe that you are right. You have to look for the solution.
Even if it is wrong.
I show such stories because it's real life. It's not just lectures that you have to know 2 + 2 has to be 4. Maybe sometimes it's 5. And about this, first they joke, then there is great guy, and the message is that we can find air. Air usually means problem, but sometimes not. If you have the white, and we take the piece, answer can be, yes, you have the cancer. Or could be, no, it's not cancer, just we made the mistake when we made the photo. So, we have to open always, because we cannot predict such situations. Air is air. And of course, this void defect could be simple like ball, but could be, I give you an example, in other bridge. Just before opening ceremony, they found that the supporting blocks are broken. And they asked for help. And we found that inside is some empty things. And when we opened, we found the many small fruits, cherries. How is it possible? And they told me, you know, it was the summertime. It was very hot. We cast it. And the girls, nice girls from the village came, look how and they gave us these fruits. And we know, we eat some, fall down, and we cast it. But I must tell you, the situation will be very, very special. I give you the most intriguing test which I did in my life. I'm sitting in my office, telephone is ringing, I take this phone and I heard, my name is Bam Bam Bam, I'm the officer of Criminal Police of Wrocław. We have information that you are specialist of concrete testing, maybe you can help us. You know, cooperation with police never is good. It's always risky, but okay. What happened? You know, we expect that one man killed his woman and put her on the line of the garage. So make the hole in the garage, put the body, then make nice floor, and forget about her. But we are not sure. Could you check without demolishing if the body there is or not? I think. I never test body. But okay, inside any body of us, there is a lot of air. So I asked him how long it happened. I don't know, but I think few months. Well, a few months, maybe a little bit disappeared. So more air inside. And we found. And they opened and she was there. Yes. So even such application. So as you see, the engineering work is sometimes very, very special. And finally, my biggest, how to say, chimney. Yes, chimney is biggest, but porażka in Polish language, my biggest loss. Okay? There is a chimney built in 1970s, where we had communist time, and it was very strong, but very bad quality. And after many years, the power plant, which is very rich now, decided to repair it, to make. And in fact, the chimney is not chimney, because real chimney is steel pipes inside. This is structure against wind. Well, they make the tender, and many companies offer the work. And one of the companies suggested we can solve the problem. Okay, they signed the contract. They have no idea about the model testing. They just take the hammer and boom, 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 boom. You know, if it is nice voice, it means it's good. If it's something is wrong. Boom, 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 boom. And suddenly, 2.5 square meters of the concrete cover layer fall down and destroy the car of director of this company. So, starts problems. No, fortunately, no one was killed. So they said, no, we cannot do like this. We have to check situation. They said, this company, boom, boom, we are specialists, the best in the world. We can do it. You know what they did? They made 120 cores, 100 millimeters diameter, from 75 maybe to 40 centimeters, because thickness is changed. And they looked for the delaminations. And they found that more than 75% of this course is broken inside. So it's delaminated. So there's no jokes. What to do? They said, we are the best in the world and we can help you and we will repair it. Okay, what they offer? They said, we will drill small holes, we put markers, and we inject by resin to glue up these two parts of concrete. Not bad, but expensive, especially drilling in 300 meters. But inside, there is stairs and some platforms. So you can make tests from inside or from outside. But from outside is difficult because you have to have special scaffolds. And what happened? They made the hole, they pushed the resin, and the resin doesn't go through. And it was too hard for them. They looked to internet and they found my name. He called me, dear Professor Moczko, we have a big problem, but for sure you will help us. Okay, I came with my colleague, my car, and they show us the situation. They say, look, there is a core, clearly broken, okay? So, and we measure from inside. From inside, from out. From inside, this is inside. So, if there is about 120 millimeters length, so it's about 3/4. So about 32 centimeters or so. Has to be delamination. So what I see the hole in the real chimney. I can take the measure tape and measure exactly thickness, 42 centimeters. Then I take impact deck up and I make boom, just close to this hole. And I get the result like this. 416. I measured 420 because it's not it's some distortion. Okay, fine. So my knowledge says no delamination. They said yes, there is delamination. I said, dear friends, there is no delamination. You are stupid. Yeah, how no? You see, I see, but there is no delamination. Starts a big fight. And the owner is listening and says, oh, I'm interested in what will happen later. Okay. So we make another place. There is a core from this place. 1, 2, 3 delaminations. I make the measurements and I have, if you see blue line and something later, it means there is delamination. Where delamination is 275 millimeters. But and this is this delamination. Of course, if you have few delaminations, you can find only the first one, because wave cannot go through, because it's probably stopped on the first one. So you can make from one side or from another side. So if it's 2, you can find. If 3, you have no chance to find it. But I said, most points which I measured was without delamination. Oh, sorry. Sorry. I was looking and I was thinking, I said, it's impossible. They are so stupid. I said, how you make the drills coarse? Oh, very simple. We connect machine and go through. Yeah, I said, we have no problems with the steel bars. Because normally, when before we will drill, we localize steel bars and we try to put the place, not cutting the steel bars. But they were not caring about it, just an accident. And the steel bars was 32 millimeters diameter, rough, each 10 centimeters. So to make the core avoid steel bars, you have to be very accurate with localization of steel bars because steel bars with each 10 centimeters. So normally you have no chance. But if they make the mistake, an accident, make place where it was more than 10, then you can find it. But normally you have to catch steel bars, and they catch it mainly. And you know, the coring machine is coming, and touch the steel bar. Bam, 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 bam. It's possible to cut, but there's no concrete in the world who can survive against tensile stresses because of this bam, bam, bam. And what they did, it was not delaminations. It was just broken concrete because of not proper drilling. And now, most important, I was enough stupid to say it. My business was say nothing. Yes, it's very special. We have to make the whole test. It will cost this money, and then we will tell you where is good, where is bad. And I told you, people, you are completely crazy. Look, there's no any delamination. It's good concrete. You just enough stupid to drill concrete in the wrong place. Of course, they promised that they will ask us. We'll make the test because it was more. But they were clever. They found that there's no problem. And I got one day work, me and my colleague, delegation car, 220 kilometers, whole day work, like not money, 2,000 Polish zloty, so 2,000. I could earn 50,000 without any problems. Because I said too much. So my message is, don't speak too much, listen what they tell. Because nice to know, nice to solve the problem, but you know, we have to earn money. We have the saying in Poland that it's not so important to work very hard. Important is to work not so hard but earn money. And the knowledge has a value. And I was, you know, enthusiast, stupid young guy. And they were clever. They only listened. When they found, was absolutely afraid. They would pay each price because they know that they cannot solve the problem. But when I proved that there is no problem, so few small denominations, no problem. And whatever later, where I showed you where is the denomination, they put injection and they came with resin and inside. Okay, so I finished my first part. I have the second part about the compressive strength, if you like, but we have only half an hour. So maybe better we have discussion. If you like, depends what you like. Because this is one story, completely new. Other interesting story is about how to define on-site with modern way compressive strength, which is the main quality parameter. But maybe next time. Maybe I can come back again. But okay, I'm in your hands.
Okay, thank you, Professor Andrew. I think it is a very interesting. In the first place, I thought that it's just like a classroom where Professor Andrew come up with all this mathematical calculation, and then I can see that the student get bored. And when it comes to the experience, I think it is very, very interesting. So especially the final one, where the elimination, it is caused actually by the coring process. It's not the actual reason. So thank you for sharing us this experience. So I hope one day that we can do further collaboration in research and also in field tests. So I would like to open any question from the floor. You guys are.
I have one question. This method, we can use it for biofoundation.
For biofoundation, we have another method.
The integration.
The concept is the same, but the pile, this is the best for the plate-like structures. You can use also, but efficiency is not so high. The same concept by what we call it impulse response method or pile testing. There's a French method, which is a special hammer with a special transducer Johor, and you make again heat, and the wave is going through and come back, and you can measure what is length of the pile. When you have the pile heated inside, if it's broken, the wave will come back earlier and show you that it's on which level there is a problem which is broken. So this is another type of test. Concept is similar, also acoustic, also not completely non-destructive, but this is well-known technique in the geotechnology. So, we did, by the way, it was developed for the pipe testing. This method which you asked. And then we translated to the plate-like because the impact deco is very efficient, but it's time-consuming. You know, boom, 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 no time and a lot of money. So we like to screen big structure fast by this hammer. Boom, I look to the picture. It's okay. Boom, okay. Boom, not okay. So I make and afterwards I come with impact deco, but only to the places which because the response is not very accurate, but gives possibility to avoid places where it's no problem. So yes, it is possible, but different technique. I have in the end some slides.
Okay, any more questions?
So, excuse me. Yeah, bro. The experience you share with us regarding the samples that was taken, chimney.
Yes.
The people made a mistake.
Sorry, I don't.
Those people that took the core samples, I mean the coring of the concrete, that was a mistake of causing the artificial delamination.
Yes.
Because they reached the reinforcement bar.
Yes.
And they kept coring. But I want to ask, is there any modern method that will accurately locate the position of reinforcement inside the concrete without?
Of course. I will say it this way. To localize steel bars inside the structure. It's several reasons. One reason is to avoid drilling place. Second is to find where they are, if you like, recalculate structure, which is only. So, if the thickness cover layer is not very big, it means 5-6 centimeters maximum. Then you can use electromagnetic measurements, and one of the devices which we use, which is from Britain, is absolutely accurate, 100%. if you have structure which is, let's say, 20 centimeters, or let's say beam which I mentioned with inside cable ducts, then cover layer is, let's say, 12, maybe 15 centimeters. Then you cannot find it by regular electromagnetic measurements. Then we use radar. That is very efficient. Radar is, but radar is very expensive. In Polish currency, is 300,000 rings. Okay. So, and this is device, standard device, is, let's say, 7,500 Polish zloty, so 8,000 euro currency. I must tell you how accurate can be. We did the test of the tunnel for tram, underground tunnel, and we had to avoid steel bars, cutting steel bars, taking course. And it was a competition. I said, I can do it 100%. They said, no, we don't believe you. If you will succeed, we will give you a bottle of the best whiskey. But if you will make the mistake, you have to give us the bottle. I said, good. 10 points. They were very nervous because they had to, I can decide, because they were sure absolutely they will lose. So they said, you can define the type of whiskey which you like. Okay, I'm not big enthusiast of whiskey, but the most expensive I selected.
How much is the most expensive?
How much whiskey cost? I don't know exactly, but I think 100 euros, something like this. And so it is possible. And I will say even more, in practice. If you employ us company or other group to make the course for you, if they will not localize steel bars in the beginning, my suggestion is please send them home, because they are not professionals. There is no reason to make, of course, nothing happens if they cut the steel bar, because I mean, but if they cut, I give you, may I give another example? May I give the example? Okay. In our town, in Wrocław, in 1997, we have the biggest flood during last 10,000 years. A big flood. And the bridge, one of the bridges, first bridge, cable bridge, first in Poland, was not destroyed, but has a big problems, because water was so high that the bridge didn't work like this, but press of the water, bridge worked in the completely unexpected direction. And because it was several beams, these beams starts work independent. They lose cooperation between themselves. And the question was, what to do? Decision was to make the holes with the beams and connect all beams, all bridge, by press-stressing cables, press-stress cables, just to force joint cooperation of all beams. You have to make each beam one side hole and another side hole. And you have to know one thing. It was a bridge, first in Poland, cable duct bridge, designed by senior of our faculty, Professor Jan Kmita, who was the god at our faculty. Few people was like this from the beginning. And his original drawing of the calc was saved at our university as, how to say, no, something very important. So before they did this, they asked young engineers, and they 2 weeks measure in the drawing and they make the marks on the bridge where they can drill. And now, please remember, never happen that you can build the bridge or other structure according to the drawings. It's not possible. Life is different. And at least in Poland, no one is scary to make the new drawing according to the real situation. And then after 20, 50 years, you come and you know nothing, because you have the drawings which are more or less good, but you have nothing about the, so you have to make the real experiment. And I went with my family to Croatia for holidays. Not 38, but 32. Nice sea. How to sunroof. My children playing in the water. I just came from the diving. I'm happy. My wife is happy. And telephone, mobile phone is ringing. My colleague was responsible for this bridge, called me from Poland and says, Andrew, help us. We have big problems. Oh, what problem? We start making the holes according to marks, and just first we cut the cable duct. I sent one of our assistants. He worked one day. He earned 1,500 ringgit, and problem was solved. Again, people believed that the drawings are true. Drawings never true. There is just recommendation for the contractor, and moreover, it's not possible. Even contractor like very much be accurate, but in many cases, contractor is not looking to the drawings. And I think in your country can be the same situation as my country, because people are very similar. So I'm not sure, I cannot say it, but I think it could be like this. So it is possible, but you have to think about it. Because if you don't think, you get problems. Fortunately, this cable with the cut, it was not very important. And till now, on my desk is cut piece of the cable from this bridge. Okay, maybe you have other questions. I'm sorry, but I'm really, it's my life. I like it. So I can force you too much. Sorry. I think it's enough, maybe.
Professor Andrew, I just have one small question.
Yes?
For a long span bridge, how do you do the scanning?
That's a good question. Our philosophy is we have two techniques. One is impact echo, and second is impulse response, which we specially adopt from pile technique to plate-like structures. So usually we divide structure, beam an example, for area about 1 meter width. And we come, and this is more or less 1.5 square meters or something like this. The impulse response, maybe I can show this easier. No, it's not here. By the way, if you like, you can write down my email. You have any contact if you like. But there is a hammer, quite heavy, maybe 1 kilogram, maybe a little bit less. And it's a special installation inside. Installation can measure force, your heat. And there is a transducer geophone, which is very sensitive, and if you make the boom exactly the same, so he can react, but it's not accurate. It's just showing there is a problem. And then you can very fast follow the structure and mark places where you expect problems. So you eliminate, usually most of structure is okay, part is wrong. So if you eliminate what is good, then you come back with impact echo, then you measure very accurately. Theoretically, you can also make the X-rays photo. But in practice, at least in Poland, it's not possible. Because the safety regulations are so strong. So in laboratory, they allowed us to do this type of measurements, with special, of course, regulation. But outside, to save people around, animals and so on, it's almost not possible that you get permission. So even don't try to develop it, because it is possible. You make the picture, you see all what it is inside. We have other, the most modern technique, which is now developed. There is a ultra tomography technique for body, you know, and the same was adopted to the concrete. There is 49 ultrasonic heads, which produce the shear waves, and you push the equipment towards the structure, and you generate 49 measurements, time measurements, and the wave is going from one head to another, and so on and so on. And then by software, you can manage 3-dimensional or 2-dimensional picture what is inside. If there is any mistakes, holes, voids, you can see it. But it's very expensive and very. We have 2 such equipments, but it's really advanced. But it's possible. But normal company cannot buy it. Our university bought it, but we have special maybe connections. Yeah, because you know it's like always. If you are familiar with this producer, you take care because you promote it. But by the way, the concept is Russian. American deliver it, and German Instruments is producer official, but it's designed by Russians. They are very good in the ultrasonic pulse technology. An example in Poland, ultrasonic pulse velocity measurements, simple measurements, does not exist now, even now, because other methods are better. Okay.
Okay. I think we finished here. I think because we are bringing Professor Andrew for lunch. So thank you everybody for turning up to today's Colloquium, and also thank you so much Professor Andrew, so for sharing us the experience, and so hope one day that our student can do collaboration with your team.
I can say during the presentation this afternoon for students, I will say something about this compressive stress measurements. So if you like, eventually you are very welcome.
Okay,
and thank you very much for audience, for being there. So kind hospitality, and it was very nice for me to be here. And I'll be very happy if I will have another chance maybe somewhere. Thanks a lot. Thank you.
Okay, for your information, Professor Andrew will be in master's class today, MKE 1033 at 2:42 to 5 p.m. And then Professor Andrew will deliver a more specialized topic. And then if you are interested, I would like to invite you for the class. So the location is at seminar room M46, I think. So, thank you, Professor Andrew. So let's.
Okay.
Oh, okay, so there is a request that can we have a group photo?
Of course.
You know, Erasmus program, they request us to take photos. Okay, come on. Terus ada penghubungin.
Where is it?
Foto-foto senyum.
If you have some time.
Welcome, sir.
Yes, we meet you again.
May I ask you later?
Ini ke sini boleh.
Okey.
Sudah mau.
Okey, tolong rapat sikit. Tolong rapat sikit.
Nampak tak?
Rapat sikit.
Lepas ini.
Okey, semua pandang kamera senyum. Okey, senyum. 1, 2, 3. Okey, one more. 1, 2, 3. Okey. Okey. Thumbs up. Okey.
Even like this.
Yeah.
Okey, thumbs up. Okey, one. Okay, one more. Okay, last. Okay, thank you.
Okay.
I'll be very grateful if you send me also such nice photo.
Ya, of course.
Especially this version. Okay, thank you very much.
Tangan.